Hello. So in this class today, we will study here about the IP addressing scheme. Now, what does this IP here refers to? IP here refers to Internet Protocol. So this is basically your Internet Protocol address here. Now, this Internet Protocol address here is basically required for the global or unique identification of every device which is connected to the network or which is connected to the internet. Now there are million number of hosts which are accessing the internet services. Now each connection should be universal. That means it should be unique for its identification. No two systems, no two devices can have ever the same IP address. So on the basis of this IP address, we are able to access the services of the internet. That means when we are when we are accessing the internet, we are assigned with a unique address. So that means that is basically here the identification of every device which is communicating with the network, which is communicating here with the internet. That means transferring information from one part of the world to another with the help of internet. You need to have an IP address for that. Now, why there is a requirement of such a universal or a unique addressing scheme here. Now, if you just talk about the OSI model of the connection. So in OSI model, we basically have 7 layers. The physical layer, the data link layer, the network layer, and above. Now this network layer addressing is basically your logical addressing, or your IP addressing here is the logical addressing, and this is at your data link layer you have the physical addressing. Now if two devices are just connected in a system and they have the physical address, so physical address here will be a local jurisdiction. Now when it needs to pass the information to the outside network, it should have here an logical address. So basically the communication here at the network layer is host to host. That means computer somewhere in the world needs to connect with another computer which is located in some another part of the world. So that means the packets are distributed here, so that need to be forwarded from one location to another. Now, if packets are distributed between two systems on the same link, so for that same link, we can have here the physical addressing. But outside, we need a global addressing scheme. For the transmission of the packets, what we need is an IP address. So, if you just look at here, that means it provides you one-to-one communication from one system to another system here. Now, for example, if we have here like a number of devices. This is device A here and wants to transmit the data to some another device D. Now, these devices here can be in some another networks. That means they are here not in the same link. Now, for example, if this is here one local area network, so it has its own interface here. Now it could be further connected to some another local area network. So this could be like your interface F1 for this network, interface F2 for another local area network, and then somehow it is here connected to a wide area network here. Now this wide area network here again has some other interfaces. Now this is another local area network, or this could be some another local area network. Now here this wants to send the data to this. So basically we have a number of links and interfaces here. So at we have here four local area networks and one wide area network. Now A has to send the data to D. Now A will send this to interface this F1, then this interface F3. But when data here arrives at this interface, which is your F1 interface, how it would be know that the outgoing interface is the F3 interface if it doesn't contain any routing information? So that's why here your network layer was designed so that we can provide here the routing information so that the packets are distributed here, they should know that where they have to go, because here we have different number of information. So if we have the routing information, only then it could go here through the right path or through the right interface. So that means here the network layer was defined for delivering the data through your routers or switches. So network layer here is responsible for creating a packet from data which is coming from another protocol and then sending it to the another device. So this is here routing your information with the help of your IP address. So IP basically has the source address and the destination address. Now destination address here is required to route the information to the correct destination or the correct client here. So we have here various networking devices for the transfer of packets. Like at the network layer, we have the routers. So when a packet here arrives at a router, it consults the routing table and finds the interface from which the packet must be transmitted. So this is how these distributed packets are transmitted here with the help of a network layer. So this is basically providing an end host to host communications, and for the unique identification for global identification, we have this IP address. So this IP address is basically an internet address which is your 32-bit long address. Now the specifications for this IP address. So this is the long address, basically a 32-bit address here. So this is uniquely and universal address. So it identifies a connection of a device to the internet in two manners, unique and universal. So that means one device will have only one and one connection. That means one device will have one IP address and no other device can have that same IP address. Now, next thing here is the address space here. So address space is basically the total number of addresses which will be used by this protocol, this IP protocol here. So this is 2 raised to power n, which is 2 raised to power 32 here, and it is giving approximately like 4294. So that means the address space here is large, and this number of addresses here are provided by this. So when we're just accessing the information from internet, if we want to access some site, we're just simply typing here the name like www.google.com or www.youtube or facebook.com here. So basically, if this is system here in India and this is some another system which is basically, for example, in another part like in US. So we can say that, like, for example, this is a Google server here. So you want to access google.com. So we are basically comfortable here with these letters here like www.google.com. Now each and every such site which we want to access will have some IP address like this. So it is difficult to remember these figures here. So that means each of these will have a corresponding domain name for that. So we're basically just typing here the domain name, and only then we're able to contact with that particular network here. Now, if this is a particular network here, so that means I should have the network ID here. Now this is a system and this is the host here. So first of all, I need to access that network here. That means, first of all, I should identify the network, and only after that I can identify the particular host over there. So that means your IP address basically has two parts. Your IP address here is divided into two parts: network ID and your host ID. So if this is your address, so it is here divided into these two parts: network ID and the host ID. So that means, first of all, for example, this is here identifying the network, and the rest of the bits here will identify the particular host, because in a large number of networks you will have different number of hosts, and you are communicating here only with the one host. So first of all, it will reach at that network, and then it will reach at that particular host. So your network ID here is divided in your IP address here is divided into two parts: the network ID and the host ID, for the network identification and the host identification. Now, in this IP address, we have the concept of the classes. That's how these IP addresses are divided. So initially, we didn't have any this classful addressing scheme. We just had a static scheme here. So, for example, if we have like n IP addresses here, and k is the net ID. So n minus k here are your host IDs. That means it will specify the net ID, and according to that, we can say that this is the number of hosts in that particular network here. So we know that we have, this is a 32-bit long address, so this is the address space here. So according to that, the various networks and the respective IDs will be divided here. Now initially we just had here the static addressing scheme. So static addressing scheme, what we had 8 bits for your net ID. So this is 2 raised to the power 32. So this is basically an octet like this. So this 8 was used here initially for your network ID, and the remaining 24 were here used for your host IDs. So that means we had here 2 raised to power 8, 256 network, and then 2 raised to power 24, which is approximately 16 million hosts here. Now, this is a very impractical ratio, because very less organizations here require such number of hosts. That means if you just buy one network ID, so it will have this much of the hosts here. So very larger organizations like your NASA, they require such kind of addresses. But initially, smaller organizations, they just don't require 16 million hosts, because no such network will have that amount of hosts here. So this static scheme of your addressing was not scalable. So after that, your classful addressing was designed. So then you had classful So for classful addressing, how they designed it, they basically divide here the number space. Now we basically know that we have a 32-bit address here, which is an octet of your port, like your this. Now your IP address has both the binary notations also and the decimal dotted notation also. Decimal dotted notation is like mostly used. Now, for example, this could be here, this something like this 0000. So from like your first 32-bit address, if we just take this 0 bit, so what I will, that means I'm just taking 10 and I'm dividing here my number space here. So I will have here 2 raised to power 31. From this 32, I have taken 1 0 like this. I'm dividing here my number space 0 0 0. Then I will have next 1 1 1. So I will have 2 raised to power 31 and 2 raised to power 31. Now, if I again take this part here. So I'm here left only with your 2 raised to power 31, and I can say my 0 here is already taken. Now I will take this one here. So 1, and again I can take another number from that, like my 0. So again I am dividing like this. So I have taken 1 0 more. Now what I will be here with your 2 raised to power 30 addresses. Now again I have 2 raised to power 30 addresses. I will take this. I will have 1 1 0 and here 1 1 1 and like 1 1 1 here. So what I will be having here 2 raised to power 29, and if I again continue here with this, taking this one, so I will have 1 1 1 0 and like 1 1 1. So now I will have here 2 raised to power 28 addresses. Now when this division was made, so they basically categorized these divisions here into different number of classes. So this, the first one here, this was your class A, this class B, this is class C, this is class D, and this is class C. So that means your class A here, 2 raised to power 31, then class B 2 raised to power 30, class C 2 raised to power 29, and then like 2 raised to power 28, 27, the different number of addresses for each class. So that means divided here the IP addresses for each class here. Now if you just see here for class A, so now only for class A here we are saying 32-bit address like this 8 8 8 and 8 here. These are your 4 octets. It could have it, this is your dotted like this dotted decimal notation. Now from here your 0 is taken for class A. So according to binary, like from 0, that will specify a class A address. If you just recall the previous division, so if any address here starting like from 0, that will be your class A address. Now if after that you have 1 0, so that will be your class B address. Then your 1 1 0 class C address, 1 1 1 0 class D, and 1 1 1 your class E address. So we're just here talking about your class C address. I'm saying here that your 1 0 is taken here. So it is left here only with 2 raised to power 7. So this forms your network ID here. So 2 raised to power 7, that means class A you have 128 networks here, and then 2 raised to power 24 here. So that means 16 million addresses here in class A. Now for example, if you just take class B here, so from class B, what you had your 1 0, that is permanently fixed. Any address here for 0 class A. Now for class A here, what will happen? I'm saying that you have 128 network addresses. So any address which will be here ranging from 1 to 128, that will be specifying a class A address, 1 to 127 here. So that will be your class A address. So for example, like 126 point like this. So this is your class A address. From this, so this is your network ID. This first octet here is for your network ID, and the remaining 3 here are for your host ID. So that means you can have practically this number of networks and this number of hosts here for your class A address. Now, in class B, we have this 1, 0 as taken here. We have 2 bits here. So here, this is your octet. This is here for your network ID and this is here for your host ID. Now from these, 2 are already taken. So 2 raised to power 16 initially we had 2 bits are occupied. We're left here with 2 raised to power 14 here. So that is approximately around your 16,000 network addresses and then 2 raised to power 16, that will be your host ID here. So similarly we can calculate here for class B, class C and class D here. So you 0 to 127 you have class A addresses here. Then 128 to 191 you will have class B addresses. Then 192 to 223 your class C, and then 224 to 239 class D, and then 240 to 255 you have the class E addresses. Now these 3 are used here. This is used for like small organizations, for your bigger organizations here depending upon the requirements. So class D and class E are basically, class D is used for your multicasting and class E here is reserved for any other future users. Now there are certain disadvantages here with your classful addressing also, because if you just see here with your class A addressing technique, so many of the IP addresses here are weighted. And at present scenario, like your IPv4 addressing scheme is exhausted also. But with the help of like your subnet mask and network address translations, the IPv4 addressing scheme is being used. But these days, instead of classful addressing, classless addressing scheme is used. So in classful, what we had a defined criteria like from 0 to 126 class A such kind of such number of hosts. Then from 128 to 191 you have class B, you will have definite number of networks and then this amount of host IDs here. Now a new addressing scheme which was devised was your classless addressing. Now it doesn't have the concept of classes. That means we don't have any class A, B, C. So if you just see an address 126 so according to classful addressing, this is your class A address, but here we just don't have the concept of classes. So this is not an class A address here. So this is basically using here the concept of blocks. Instead of classes, blocks are used here. So this basically use here CIDR notation. Why this is using here CIRDA notation? Because if we just don't have classes, we would have here the problem of identifying the network and what is the host. So we're using here CIDR notation, which is a classless inter-domain routing notation. So here we simply have the block ID and your host ID. This is the concept here. We have block ID and the host ID. So for that, the identification of the network and the host, we have the CIDR notation. So how it works? So this notation is like this: A dot B dot C dot N. So this slash N, this N here is the network ID. For example, if I have an address here like this, 20.50.10.100 and then divided by 20. Now according to Classful, you will say that this is a classless address. This slash N, this N here is the network ID. So that means this is the number of bits here used for your network ID. 20. Network ID is your 20. So for host, we know it is n minus k. 32 minus 20. So 32 minus 20, we have here 12. Host ID 12. So 2 raised to power 12. So this is the number of host IDs you will have here for this network. So this is how the division here is made in your classless addressing scheme. We don't have the concept of classes, we just have the block and the host ID. So this is the CIDR notation, the slash n. So this is how we can identify the network and the corresponding host and the number of IP addresses. So this is here about your IP addressing scheme, that how the IP addresses are designed or they are allocated. So this is basically 32-bit address having network ID and the host ID in your classful approach. Then we also started about the classless approach in which we had the CIDR notation. So this is all here for today's class. Thank you so much.